Right, let's have a look at this example. Integration is the reverse of differentiation. So if you were to differentiate this using our rules for differentiation, the power rule, the 3 comes down, cancels with the third there, x to the 1 less, which is x squared. So this differentiates to that. Similarly, the 4 comes down, 4/4 of 1, x to the 1 less, which is 3, and e to the ax differentiates to e to the something, multiplied by the something differentiated, which is 2. 2 halves of 1, so there's 1 lot here. So you can clearly see that these things differentiate to that. So if integration is the reverse, then it just means that the integral of x squared is equal to x cubed over 3. And the integral of x cubed, we write dx here, we just snick it in. That's how we write the integral, is equal to x to the 4 over 4. And the integral of e to the 2x dx is equal to half e to the 2x, wasn't it? Because that's what it differentiated to. Now, when you differentiate, any constant differentiates to 0. So you can think of this as x squared plus 0. So what pops up in an integral is a constant of integration. So an integral of 0 is a constant. When you differentiate a constant, you get 0. So we don't usually write plus 0, but that's why the constant of integration always pops up. So we put a plus k here. Okay, and that leads us to our table. If we look at those first two, see we raise the power by 1 and divide by that number. Raise the power by 1, divide by that number. So here's the rule then. There's only one exception when x is minus 1 here. So this rule is for n not equal to minus 1. That's covered here with the logarithm case. So there's the rule for powers. Constant on its own, or the derivative of kx, x goes to 1, so you get k. This number on its own, the constant, goes to 0. So you can see how, if you look at it, you can check that these do differentiate using the table of derivatives. So the log differentiates to 1 over x, and the constant goes to 0. So I hope you can see that we can very easily extract the integral table from the table of derivatives by essentially writing it the other way around.